Hello and welcome. This is the single linked list part 1. In this video, what is a single linked list? I will try to answer this question. I will do the implementation of the structure, the function addFirst, the function addLast, removeFirst, removeLast, and finally the function print. Then I will show you the code working. What is a single linked list? Imagine that you have some numbers and they are very disorganized, they are out somewhere, okay, and we need to group them together. So we can iterate them and add more, remove, search, etc. To do that we need to link them together like this, okay, and then we need to add something to hold this structure. Okay, we will call it head and it will have no number, okay, no data here. Also it will point to the first element. By the way, these are called nodes, okay, this is a node, this is the second node, another node, etc. And the head is a node too. Okay, but is a node is a special node, is a node that have no data, and we can know that is the first one that points to the elements. So a linked list is just that. This kind of structure can have numbers, or it can have another kind of things like a person. Okay, so this is the definition of a linked list, is something that groups data together. It can be numbers, it can be the information of persons or cars or etc. So let's go to the fun part, the implementation. The first thing to do is implement the structure. The structure is called node. It will have data and it will have a next that is actually pointing to another node. This data is a integer, our number, okay? In cases that the node is the last one, it will point, the next will point to null. Let's do it. Type def struct node and it will be called node t struct node pointer next is our next node and int data, that is our number. So now that we have our structure, we need to create our structure and delete our structure. Okay, so we will create the new node function and the free node function. Here again we say that node t pointer new node is our function to create a new node, okay, and we say that node t pointer result is equals to malloc size of node t, and then we return the result, and before returning we say that the result next will pointing to null, because we don't know where to point in that moment. After we can declare the free node and we need to receive a node, so we declare node t pointer, and inside the function we just call the free function free the node. So now that we have the new node and free node implemented, let's implement the addFirst function. We have this structure, okay, and we have a new node and we need to point the next of this new node to the next of the head, this guy, and after that we have to point the next of the head to this guy, okay, and then this will be destroyed. Again in the code we declare void addFirst, okay, and it will receive the head, that is a pointer, a node t pointer head, and it will receive also a integer that is our data, the data of the new node. Then what we have to do here is create a new node, node tPointer, node is equals to new node, our function that we created up here, new nodes. We are calling this function. So instead of repeating this code, we just have to call this function. Then we say that node data is equals to the data that we received there as a parameter. Next, we say that the node next is equals to the head next, like explained in the slide, and the head next is equals to the node. So it's simple, right? The next function is the addLast, and we have this structure we want to insert here at the end. So we have a new node that we have to create, and then we have our head, and we will move from the first element to the last element. Okay, then we point the last one next to the new node, and this null will disappear. Okay, it's just that. So let's implement the addLast. Void addLast receives a node tPointer that is our head and integer data. We need to create a new node, new node, like we did in the addFirst, and we say that the node data is equals to data. Okay, then we must move from the head towards to the last one. So we say node t iter, that is iterator head, and while iter dot next is different from null because the last element is pointing to null, say that the iter is equals to iter next. So with this code we are moving the iterator to the last element, and after reaching the last element we say that iter next is equals to our new node. Simple like that. So what comes next? The next is the remove actions. Remove first. We have this structure of nodes, we have this node, and we want to remove this guy. Okay, so we must point the next of the head. Instead of pointing to this node, it will point to this node. To do that, we must say that the head dot next is equals to the add next next. Okay, and then we say that the head next is equals to null. This seems a little confusing. Okay, so let's see this in the code. Void remove first and receives a node t that is our head. Then the first thing that we must do is check the list is not empty. So to do that we say that head next is different from null. If it is different from null, it means that the linked list is not empty. So if the linked list is empty, it will do nothing, it will go away. If the linked list have elements, it will do something that we will describe next. Node t to remove, we need a reference to the guy that we want to remove, and the guy that we want to remove is the head next. Again, we say that head next is equals to the head next next. Okay, this is this action, head next next, this guy. Then we say that to remove next is equals to null. With this we are saying this. Okay, we are removing this connection, and after this we say free node to remove. Okay, this can seem a little strange at first. We have this function free node for a node because we can say free to remove directly, right? But you will understand in a future video why I did this in this way, okay? For now, let this be just like that, okay? And the next action is removeLast. Again, we have this structure, okay? We want to remove this guy, the last one. So to do that, we must move from head towards to the previous of the last one, and then we say that the previous will point to null. So let's see how this fits in the code. We declare void removeLast and receives a node t pointer, that is our head, okay? We declare node t pointer prev equals to null and a node t current, that is the head. Then while current next is different from null, while we don't reach the last position, we update the prev equals current, and current is equals to current next. So with this code we are moving from the head to the last element, and this will have the previous element of the last element. The current will be here and the previous will be here. If the list is empty, the previous will be null, because this will not run. So we had here a check. If previous is different from null, we will do something, that is removing our element. If not, we just go away, okay? So previous next is equals to null. We are doing this action, we are destroying this link and pointing to null. Next we say free node current node, okay? So with this action we are destroying these elements. Actually I have a second version of this function, so I will implement the second version. It is a little more complex, it's simpler, but it's more difficult to understand, so I think that doing the first version is more easy for you to understand the second version, okay? So let's do that. Let me put this smaller and I will call this version 2, and I will have a void removeLast again, node t pointer ahead, and we say that if head next is different, and I did a mistake here, is different from null, we do something. So if the list is not empty, we will do something. What we will do? While head next is different from null, head will be updated to head next. So you can see that this code is more difficult to understand than the previous one, okay? Then we free the node head next, okay? With this code, let me show you. We are saying that while head next is different from null, the head will update to the next node, and then we will ask again, head that is here next is different from null? No. So the while loop will stop, and we say that head that is pointing to this guy next, free this guy. We don't need this guy anymore. This code is doing just that, okay? Then we say that head next is equals to null, is pointing to nothing, okay? We are doing this, we are destroying this link and pointing to nothing. So the next thing to do is the print function, the last function to implement, and this is the easiest one that we have to do. We have a list and we have to move from the head to the last one, and while we are moving we are printing the content of the node. Okay, so let's do it. Void print linked list receives a node t pointer, that is our head, and first we must check if head next is equals to null. We must inform the user that print f list is empty, new line, okay, and then we just return, we go away. Next, while head next is different from null, what we must do, we say that head is equals to head next, we move to the next element, and then we do a printf data, and we will print a decimal because is an integer and is head data, like this. Okay, is simple like that. So the next thing is our demonstration of the code running. Okay, let me explain something before we go to the demonstration. I have this section of the code, the main. I already have here some functions that help me get the chars of the user and read a line, for example, of the user input. Okay, and I have this function, the main function. In the main function I create a list, a new node. Okay, then I display this console menu, and then I get a char from the console menu, that is the operation that we want to perform, 1, 2, 3, 4 or 5, print, addFirst, addLast, removeFirst, removeLast, and then we have a switch that receives our operation, and if it is the one, it will print our list that we declared here. Okay, if it is the insert first, we ask for the data and we read an integer from the user input, then we call the addFirst function that we created before. If it is the addLast, the code is very similar. We read the integer and then we call the addLast. Then the remove, we just give the list, and the removeLast, we give the list. If is another character, we go away and the program exits. Okay, so let me copy these and go to the REPL, paste and run these. Let me put these bigger so you can see. And first we say print, and it says that the list is empty. Let's say addFirst, and we say 1, 2, 3, print 1, 2, 3, addFirst 1, 3, 4, print 1, 2, 4, 1, 2, 3. Let's add last, addLast, and 6, 6, print 1 through 4, 1, 2, 3, 6, 6 is the last one. Let's remove the first element, this guy. So we say 4 and print again, the element is gone. Let's remove the last element, 5, and print, and the last element was gone too, the 6, 6. Okay, so let's see. So what comes next? Next, I will change the node to have more complex data. For example, the information of a person name and a person age, for example. Okay, and stay tuned. This will continue. So hope you like it, and see ya.